Let's continue our discussion of section C, that is the deep learning part. Let's proceed with the question number 16, that is about probability. When a fair die is rolled twice, there are 36 possible ordered outcomes because each roll has 6 outcomes. To find the probability that the sum is 7, we list all the pairs by brute force: 1 6, 2 5, 3 4, and the opposite pairs 4 3, 5 2, and 6 1. Since these are ordered pairs, they also count. So the probability is simply expressed by 6 out of 36. This simplifies to 1 over 6. So this is a rather easy question. Let's proceed to the next one. For a binomial distribution of parameter values n equal to 10 and p equal to zero point 0.5, the expected value is simply given by the multiplication of n and p, which is 5. This can be interpreted as that we, on an average, we expect 5 successes out of 10 trials. Let's proceed to the next question. This is about the parametrics of evaluation of a machine learning model. So let us examine this. We know that the relationship of r square is equals to rss upon is equals to 1 minus rss upon tss. So when r square is given as zero point 0.8 and tss is given as 100, we rearrange the formula to solve for rss. So we get the value of RSS as 20. Thus, 20% of the variability in the data remains unexplained. Let's proceed to the next question. That is question number 19. The In linear regression, gradient descent rule updates the weights for W Walras operator W minus alpha x. The alpha into x of this is simply the derivative of the cost function with respect to that weight. So in gradient descent, the weight update follows the principle of moving opposites. So the gradient, to reduce the cost function, we apply this rule that the weight is truncated by weight minus alpha, that is the learning rate, into the partial differential of the cost function with respect to that weight. So alpha is the learning rate, and the derivative tells us the direction of steepest ascent, which negate the order of descent. So this is how we obtain the minimum value, the best possible value, where the loss function is minimized. The next question, question number 20, is that for a normal 1 0 distribution, what percentage of data lies between -2 and +2? So let's use the empirical rule, that is the 68, 95, 99.7% rule. The approximately 95.4% of data lies between two standard deviations of mean. So between -2 and +2, we can capture almost all the central distribution, right? So the mean is 0 and standard deviation is assumed to be 1, and the range is 2 -2 standard deviation to +2 standard deviation. Proceeding to the next question. For k-fold cross validation with k equal to 5, each iteration uses what percentage of training? So this is also a simple question. The data is split into 5 parts. During each iteration, 4 folds are used for training and 1 fold is used for testing. Therefore, the percentage is 80%. 80% of the data is being trained on, and 20% of the data is being used for validation purposes. Right. So it's an easy question again. Let's proceed to question number 22. Compute precision if true positives is 40 and false positives are 10. So precision is a proportion of predicted positives that are actually correct. So this can be given by TP upon TP plus FP. So we substitute the values of TP and FP that is basically uh, true positive is given as 40, and the 40 plus 50 plus 10, so that is 50. So that this is zero point 0.8. So the model achieves 80% precision. In the next question, we are asked to compute the F1 score, right? So and the recall is given as zero point 0.8 and precision is given as zero point 0.4. So the F1 score is basically the harmonic mean of precision and recall. So we multiplied precision and recall and divided by the addition of precision and recall. So this is the approximate value that we get, that is 0.53. Simple formula based question, right? The next question is, a model gives TP true positive equal to 70 and true negative equal to 80, false positive equal to 20, and false negative equal to 30. So there are 70 instances of a true positive outcome, there are 80 instances of a true negative outcome, there are 20 instances of false positive outcome. This is type 2 error, and false negative instances are 30. So we need to calculate the accuracy. Accuracy is simply the measure of correctness. So that will be the true positive plus true negative rate divided by the total of all predictions made. So this simply boils down to 150 upon 200, and that is 0.75. So this basically means that our model is 75% correct in all the cases. Let's proceed to the next question. The next question is, for a Poisson ratio, for a Poisson distribution, given that the lambda is given as 3, the expected value is what? So the expected value is simply the occurrence is 3, because this simple formula for Poisson distribution is simply the value of the lambda parameter. And again, this section is over, I guess. These concepts are bedrock for many statistical and machine learning methods. So understanding these and the intuition behind these is pretty critical for us. Thank you.